Parasitic protozoa, the kissing bug, and Chagas disease, a study on Trypanosoma cruzi. Trypanosoma cruzi, or T. cruzi, is a flagellated protozoan parasite that is responsible for causing the illness known as Chagas disease. Chagas disease originated in Latin America and is relevant to humans because it infects over 8 million people and kills around 10,000 people a year. The classification of T. cruzi is as follows, beginning in domain Eukaryota and ending in species Trypanosoma cruzi. Chagas disease, which is caused by T. cruzi, gets its name from Carlos Chagas, the man who discovered it in 1910. He named the bacteria Trypanosoma cruzi after a mentor of his, Oswaldo Cruz, who was a renowned epidemiologist in Brazil in the late 1800s. Chagas disease is spread mainly through insect vectors, mainly the redu bug, aka the kissing bug, who passes on the bacteria through feces. The disease is communicable via insect to human, but is not contagious or transmitted from human to human contact. Chagas disease has both an acute and a chronic phase. In the acute phase, symptoms can be mild or even non-apparent and include common things such as fatigue, aches and malaise, fever, and nausea. This phase can last for a few weeks or months. The chronic phase can result in cardiac or gastrointestinal complications that can lead to enlarged organs, heart failure, ingestion digestion inability, and death. This chronic phase can last many years or even a lifetime. T. cruzi's portal of entry is through wounds on human skin, oral nasal mucous membranes, or even conjunctiva. This parasite invades the host cell, transforming into an amastigate, then multiplies by binary fission, becoming a trypamastigate. When the host cell ruptures, the trypamastigates travel through the bloodstream and infect new cells. To further research the complicated life cycle of T. cruzi bacteria, I chose two articles. First was the popular article Perspective on Trypanosoma cruzi-induced heart disease, which helped inform me of how Chagas disease can affect the human heart via heart failure, cardiac arrest, and other terminal heart complications. My research article was Biological Characterization of Trypanosoma cruzi epimastigates derived from trypamastigates isolated from Brazilian Chagasic patients. While there was not a specific hypothesis stated in the article, the goal of the researchers was to observe and analyze isolated epimastigates in order to find better treatment for Chagas disease. In order to do this, the researchers took 8 T. cruzi isolates from chronic phase Chagas patients, which were differentiated into epimastigates, and then they made an analysis of their biological parameters. Included in their research and analysis was graphs of the epimastigates growth curves as well as optical microscopy photographs. Table 1 below documents the epimastigate's biological parameters. Additionally, oxygen consumption rates, or OCR, were recorded and determined in the absence or presence of CCCP, an ATP synthesis disruptor, over 3 graphs. The first graph shows OCR of the isolated epimastigates that were non-permeabilized. The second graph shows OCR in digitonin permeabilized cells in the presence of succinate. Digitonin is a steroidal organic chemical, while succinate is a dicarboxylic acid. The final graph shows OCR for epimastigates, again digitonin permeabilized, but this time in the presence of TMPD, an easily oxidized chemical, and ascorbate, a form of vitamin C within the body. The conclusion of the researchers was that the OCRs of the T. cruzi isolates were higher in the presence of TMPD/ascorbate. They found the respiratory control ratios of the isolates to also be similar and concluded that the coupling of the mitochondrial respiratory chain and ATP production is of equal value in the T. cruzi isolates. In conclusion, the biochemical characteristics the researchers analyzed show heterogeneity between the isolated epimastigates that were differentiated from chronic Chagas disease patients' trypamastigates. Chagas disease is considered a potential emerging disease, but has no vaccine nor drugs to prevent infection. If infected, the best form of treatment is an antiparasitic in order to kill the parasite, and symptomatic treatment in order to curb the signs and symptoms of infection. The only drugs found to be effective are the triazole derivatives nifurtimox and benznidazole, which are only effective in the acute phase and run the risk of dangerous side effects. Thank you for listening to my presentation.